We are talking about factoring polynomials, and we are going to learn about 3 different strategies that will help us factor polynomials. The first one is greatest common factor, which is what we are going to learn about in this video. For our scale, this is a level 2 skill, but this level 2 skill is heavily used in the level 3 questions. So it's really important that you can understand greatest common factor to the best of your abilities. First, let's figure out, okay, what does greatest common factor mean? What am I asking you to do by that? So, the strategy of greatest common factor means find the largest factor that all terms have in common and pull it out. The key word here is it has to be what all of the terms have in common. The second thing that you need to know about greatest common factor, or GCF, is that this strategy should always be tried first when you're trying to factor. So let's take a look at some examples so that we can really understand what this means. Example number 1, 4w plus 8y. I have to figure out what is the greatest or the largest factor that these two terms have in common. So I'm going to ask myself, what can both of these numbers be divided by? Well, 4 and 8 can both be divided by the number 4. So I'm going to put the number 4 in the front, and now I'm going to fill up my parentheses. Now what I'm going to put in my parentheses is what is left over after I divide each term by the number 4. So the first term was 4w. If I divide by 4, all I'm left with is w. The second term was 8y. So if I take 8 divided by 4, that's 2, and then the y stays there. I have now factored this using GCF. Now let's look at example 2. 12x squared plus 2x. First, let me ask myself, what can both the number 12 and the number 2 be divided by? They can be divided by 2. Now in this problem, we have something else to consider. Because both terms have the variable x, I have to see how many x do the two terms have in common. Well, my first term had 2 x's, and my second term only had 1 x. So if I think about how many x's do the terms have in common with each other, they each only have 1 x in common with each other. So my GCF, or what I put in the front, is going to be 2x. And again, to fill up my parentheses, I have to put what's left over. So when looking at the first term, if I go 12 divided by 2, that's going to give me 6. And then my first term used to have 2 x's, but we took one of them out when we did the GCF, so there's only 1 x left. Now looking at my second term, 2 divided by 2 is 1. And then I had 1 x, but I took that x out, so there's no more x in my answer. And my final answer would simply be 2x times 6x plus 1. Let's see if we can pick up the pace a little bit. Question number 3. We have 6g minus 9f plus 3h. This time I have 3 terms. So I have to figure out what can all 3 numbers be divided by. Well, that answer is 3. Now, if I look at my variables, each term had a different variable, g, f, and h. So I can't pull out any variables because they don't have any of the same letter in common. So now let's fill up my parentheses using division. 6 divided by 3 would be 2. Keep the g after it. Negative 9 divided by 3 would be negative 3. Keep the f after it. 3 divided by 3 would be 1. And keep the h after it. I have now factored using GCF. Example number 4. Again, I have 3 terms. I have to figure out what can all 3 terms be divided by. Well, 20, 5, and 15 can all be divided by the number 5. But now I need to look at my variables to see what they all have in common. Well, my first term had 4 x's, My second term had 3, and my last term had 2 x's. So, how many x's do all of the terms have in common with each other? Well, all of them have at least 2 or more x's. So that's how many x's I can pull out. Now let's fill up our parentheses. 20 divided by 5 would be 4. I had 4 x's, but I took 2 of them away, so I have 2 left. 5 divided by 5 is 1. I had 3 x's, but I took 2 away, so there's only 1 x left. Now with my last term, negative 15 divided by 5 is going to be negative 3. I had 2 x's, but I took 2 away, so I don't have any x's left. Example number 5. Again, 3 terms. I need to check out what can all 3 terms be divided by. Well, 3, negative 21, and 15 can all be divided by the number 3. And I have to look at my variables. X to the 8th power, x to the 6th power, and just an x. What do all 3 terms have in common with each other? Well, they all have at least 1 or more x's. So the most that I could take out from each one would only be 1. Now let's fill out my parentheses. 3 divided by 3 is 1. I had 8 x's, but I took 1 away, so I have 7 left. Negative 21 divided by 3 is going to be negative 7. Had 6 x's, took 1 away, so that's x to the power 5. My last term, 15 divided by 3, gives me 5. And then I had 1 x, but I took it away, so there are no x's left. Now let's look at question 6. Question 6 looks a lot different because there's just more things there. But let's first determine how many terms does this polynomial have. Well, there's one term right here and another term back here. I have to figure out, what do these 2 terms have in common with each other? Well, I can see that this term has an x plus 1 and this term has an x plus 1. So that's going to be my GCF. They both have it in common. So I'm going to put that x plus 1 in the front, and I'm going to put everything that's left over in my back parentheses. So if I take the x plus 1 out of each term, I'm left with 4x from up here and a plus 6 from back here. There, I factored using GCF. Let's look at question number 7. First, we need to determine how many terms are there. Well, remember, terms are separated by plus and minus signs. So again, this problem has 2 terms. Now, what do these 2 terms have in common with each other? Well, they each have an x plus 5. So that's our GCF. That's what we are going to put in the front. They both have that in common with each other. Now my back parentheses are going to be everything else that's left over once we take the x plus 5 out. So that would be the 3x minus 4 and the plus 9x. Now I could take this one step further to simplify. The x plus 5 is going to stay x plus 5. But my back parentheses have like terms in them. I see a 3x and a 9x. They are like terms, so I'm going to simplify it by combining them. 3 plus 9 would give me 12x, and then I just keep the minus 4. And this would be my final answer by factoring using GCF. One last problem. How many terms do I have? Well, terms are separated by plus and minus signs. So I have 3 terms. What do all 3 terms have in common? The x minus 6. So that's my GCF, and I'm going to put that in the front. Now, everything left over goes in the back. So the 2x, the 3x plus 9, and the minus 11. Now let's simplify a bit. The x minus 6 is going to stay the same, but I can put the 2x with the 3x, and I could put the plus 9 with the minus 11, because they are like terms with each other. So 2x plus 3x gives me 5x. 9 plus negative 11 gives me negative 2. And that's my final answer, factoring using GCF.